Hello. In this assignment, we have used the supervised learning regression models, which gives the continuous values. We are using the diabetes data set. Firstly, we have imported the data and all the necessary libraries for this assignment to evaluate its performance and to visualize the results. Then, with the help of the histogram, we can display each features which are present in the data set. Thus, we can know the distribution of the data present in this data set. Now that we have our data, we need to split our data into 90% for training and 10% for the test set. Before that, we need to perform stratified random sampling. Um, so just by doing the stratified random sampling, it throws the error stating the least populated class in the output variable is few. So I have used the age, I have divided the age feature into groups, 10 groups, and the numbers will be assigned accordingly. So that way the random sampling can be generated. So thus we after splitting we'll get 90% for the training and 10% for the test set. Now to see the correlation between target variable and all the features, we are displaying a correlation matrix to see which features have high or low correlation to our target variable. After this, now with the training data set, we can train our regression models and predict. So first is our linear regression model. And then we've imported the packages of linear regression and the evaluation models. So, yeah, so we're taking the linear regression, and then to evaluate, we are using the root mean square and mean absolute error. So these are the values for linear regression. Then only for the two samples of the testing set, we need to predict the target value. So for the sample 1, the predicted target value is 103.39 and the actual value is this. So the difference between them is 25. And as well as for the sample 2 of the testing set is 160 and the actual difference is 245, the difference is 84. And for measuring the regression model, for the linear regression, the RMSE, which is the root mean square error, is 53. Actually, the root mean square should be the minimum value, only then it is a good model. So to see whether the performance of the trained model is overfitting or underfitting, I have used the learning curves. So from this to check if the RMSE mean score is greater than of the RMSE value, then it is said to be underfitting. If the RMSE mean score is less than the root mean square value, then it is overfitting. So for the linear regression, it is said to be underfitting. And the second model we are using here is ridge regression. So after using this function, after training this ridge regression model, the RMSE value is 56 and the mean absolute error is 46. And then for to see the performance of the training model for the ridge regression, and again I'm taking a learning curve which splits the data into training as well as validation, and then this chart plot will be generated accordingly. And to check, I'm taking the mean. So if it's greater, it will be underfitting, or if it's lower, then it will be overfitting. So for the ridge regression, it is overfitting. Then the RMSE value tells us how concentrated the data is around the line of best fit, and it is a good measure of accuracy and also to compare the forecasting errors of different models. So that's how we have used two regression models. Thank you.